Welcome to TechbrothersIT. In this video, we are going to take a look on Windows functions in PySpark. We'll be covering these functions: cumulative distance, the dense rank, lag, lead, NTILE, nth value, percent rank, and row numbers. So let's start with our session with some sample data. Here is my sample data, and you can see that I have name here, and then I have departments here, and then I have a sale here, and this is the date on which that sale was made. So just remember that we have a sale for only 3 days. So we have January 1st 2024, and then we have January 2nd and January 3rd. That's the sale date we have here. And now these are four names what I am repeating over and over in these 3 days for different departments. So different sale is there. And now if we will take a look here, we have schema variable here, and that we have employee, department, sale, and sale data. These are the column we'll be using for this sample data. Here I'm creating a data frame called df spark.create data frame function is used to create the data frame, and we use sample data here as a parameter, and then we use the schema as a parameter. Now once this data frame is created, we can use the df.show to see the data frame. So let me run this one and show you as a kind of table, so we will able to kind of remember what exactly we have, and then we apply these different functions. Here is my original data frame table, and you can see right there we have employees, department, sale, and the sale data. One thing you would like to remember that here are some values I have actually put together, and which one was that? Just remember that one of the value for the Ben, so see right there we have Ben in the sale department, and his sale amount is 5,500 here, and on January 1st, and also the same amount of sale he has in January 2nd. I will show you why it is important, so we are going to take a look on this one. I just want to, when we are going to partitioning, and that's where this is going to be playing a role here. Now what we will be doing, how we will define the Windows specification. So partition by department, so we will be grouping by department, and then grouping employees by the department. That's what goal is right here. So you see that here I'm defining a variable called Windows_spec, and here Windows partition by. So this is a keyword you will be applying, and here you will provide on which you would like to partition by. So here we are partitioning by department, and then we are ordering by sale. So order by sale, ranking employees with their department sales. So these two things are important when you are creating the or using the Windows function. First, how you would like to partition the data, and second, in which order. So see right here we have these are different departments. So if I would like to partition this data according to this department and then sale, so then that's how the data will be put together and grouped, and then all the functions will be applied on that one. So remember that again, if you don't want to use this variable here, you can always paste the code right here wherever you need it in the row number or other functions and all that. You can paste the code there, so no problem. But it's very clean way to put this together here. Just create a variable and then provide the partition by here, and you would know that on which column you are doing the grouping or partitioning, and then which column you are sorting. So you have this one, and then you keep using this variable wherever you needed it. Okay, let's start with the row number. So row number function assign a unique sequential integer to each row within a Windows partition. So starting from 1, useful for the numbering rows within the group, like assigning an ID to each employee within a department. So that's important. So here we will be doing, I'm gonna delete this, there is extra. Okay, here we have df data frame, that's our original data frame, and I'm adding a new column by using with column function here, and the number name of that column is gonna be row number, and here I'm saying row number over, and then I provided this variable here. So partition by department, order by sale. So I'm going to add the row number to each of the record, and I'm going to show how exactly it will look. So here it is. You can see that we have partition by department, remember. So we have group by this department. So HR records are all together now, and now we have a order by sale. You can see that 5300 and 6000 and 6100. So you can see these values, and now that row number will be applied to each of the value. So the very first record that we have right here is get the number 1, the second row is going to get the number 2, and then the third row is going to get the number 3 row number. Now what happened as the department changes, so that's what the partition is, right? So that's how we are grouping. As the department is changing, the sequence start over again. So you see right there, it again started with 1 2 3, and that's and then we have the third group, that's for sale, or that's our partition. You can call it partition group, whatever you want to call. So this is a portion we have for sale, and then it's ordered by already in the sales amount. And now you can see that we have numbers starting with 1 and keep going all the way to 7, and this is how you will add the row number. But sometimes we have the scenario where we say like, hey, guess what, I want to just add the row numbers and I don't really care about the partition. So that's possible as well. So here I'm going to go ahead and add that row number for you. So here I'm providing a new WindowSpec overall, and I'm saying Windows order by column sale data. So I'm just ordering the data by the sale date here. Now why it is important here? Because the order by is still important, because you want to be at least like know for which order you want to number those records. And here I totally ignore this part, so I did not use this part at all. So I did not do any partitioning here. I'm only using the window.order by and only saying like, hey, on this column do the order by. So we are not partitioning this data at all. And here I'm adding a new column on the data frame df, and with column function, call this new column is the overall row number, and then row number over, and then we'll be using this spec here. So now if I run this one, what's going to happen, it's going to add the sequence number to all of the records. So if you see right there, and right here you can see that we have sale date, that's what we order by. So you have see all the records with January 1st till here, and then January 2nd and January 3rd, and you can see that we have now added the number, and these numbers keep going because we did not do the partition. We are just adding the row number to all the records, and we did only order by the sale data. So that's why in the partition, each time the partition changes or the group changes, then the sequence number restarts. That's how we have seen in the first example. Okay, great. Now we are going to go ahead and take a look on the rank function. The rank function determines the rank of each row within its Windows partition based on the order. Rows with the same value receive the same rank, and the next rank is skipped. So remember that I was trying to show you a value here for Ben, like we have this sale 5500. I have this twice for Ben on different days. So, and our partition, remember, is happening on department and sales. So let's take a look. If we will run the rank, what will be output? So here is my data frame df, and I'm adding a new column with the using the function with the column, and the name of the column is going to be rank, and here I'm providing or using the rank function, and the syntax is rank over, and then we have to provide the Windows specs. So here the Windows spec will be like, okay, Windows partition by department order by sales. Okay, so now if we execute, what's going to happen? I'm going to show you that. So here's our output for the rank, and you can see that in the HR it is order by sale, right? So we have a group by HR, department, and then order by sales. So it started getting the number 1, 2, 3 just fine, because there is no repetition happening in the sale amount here. And for the marketing is the same thing happening here. You can see right there. Okay, but in the sales department there is one record. So let's say sales department, this is first record, and then second record, fine, and then a third record comes for the Ben, and the date is different, we know that, but we are not using date here for anything here. So we are using the department for the partition and sale for the order by, sales for the order by. So here you see that for Ben we have this record sales 5500 and it got number 3 number rank, and then again sales with 5500 got 3, but next number for sale did not start with the 4. So that's why it will skip the next number. So let's say if you have we have 2 records for 3, right? So number 4 is missed. If we will have 3 numbers for say here for number 3, then it will start with number 6. So you can see that it skipped the number. So if this is 3, this is also 3, this should be 4, right? And if we will just have row numbers, so then that's why the next number is 5. So you get the idea, like it's gonna skip the number. If they are repeating over and over, then the next number is going to start with the actual sequence what it has. So 4 will be missed here, and it is missed right here. Okay, so this is how the rank will work. But there is a solution. If we don't want something like that, there is a dense rank that will take care of that. So instead of like 335, we want a 334, that we will use a dense rank. Similar to the rank, but assign consecutive ranks without gaps, even when there are ties. Okay, if multiple rows have the same value, they get the same rank, and the following rank is the next integer. So that's what exactly is happening. So data frame here, then with column, new column, we are adding a column called dense rank, and here we are saying a dense rank over and then providing the specification for the partition by department, order by sale, and then showing that. So now we are going to go ahead and execute this part, and you're going to see. So you can see right there for HR just fine, because theirs are just unique records, and they are getting the dense rank 1, 2, 3. And for marketing again 1, 2, 3, because the values are different. And here we comes with the for sale. So first sale it is 1, second sales 2, and then the same value comes for the sale, right? This one and next one. So that's why it got 3 and 3, but then it did not skip the number. So it started with 4 for the next record. So that's what the dense rank will do. It will not skip the numbers. It will just keep assigning the same number to the same partition and whatever the values are there, and then start with the next number. So that's how the dense rank will work. So depending on your scenario, sometimes you have to group by, you have to use the rank, sometimes you have to use the dense rank. It totally depends upon your reports or whatever the data analysis you are doing. Now percent rank, it calculates the relative rank of each row within its partition as a percentage. The result is in the range of 0.0 to the 1. So here is it is. So df with the column and percent rank, and then that's the name of the column we are providing. Here is we are saying, hey, apply percent rank function over and then a WindowSpec that we have a partition by department and order by sales, and that's the specification we have. And then we are going to use show to show you the record. So here it is, and you can see that it is returning us a percentage rank. So you can see that for HR it is for 53, so it is it's starting with 0, then we have HR 0.5, then we have HR 1. So there were 3 records, and we got 0.0, 0.5, 0.1, 1, and then for marketing same. But here is the sales. So starting with the sales, and you can see that it started with 0, then is the next percent rank comes to 0.16, then next one 0.33, next one 0.33, and then 0.6, and then 0.83, and then eventually we have a 1 for that. So this was also confusing for me. Okay, so I haven't used this much in the real world, and I said, okay, let me further investigate and show you maybe in a more visual and how exactly it works. So here's a formula. So that is used for percent rank. Percent rank is equal to the rank that we have already calculated in the very first second formula, like how to calculate the rank, and then -1 divided by total rows in the partition -1. So that's the formula. That's how it will get calculated. So now it is more gonna be easy to understand when we apply on the sales data. Remember that we have sales data and we have department sales, and then this is our sales. So this is already in the order, and this is the first rank that we provided to our record, right? So according to the formula, So rank minus the 1 minus 1, 7 minus the 1, so that's our total rows right there. So 7 is our total, and then we did a minus 1. So this is the 1 minus 1, so rank minus 1, then divided by total rows minus 1, so that gave us 0. For the next you have a second rank, then you subtract 1 out of it as per the formula, divided by 6. So that's our this number, right? So 7 minus 1 is equal to 6, so keep dividing with 6. So this is how you came up with 0.16. Then for the next one, see, remember that we have rank 3 and 3 because it was the same value, that's why there was same rank. And then you have divided by 6, so you got this value, same value for these two numbers here, but in the rank, then if you have two consecutive same, or maybe more even consecutive same, that's the same rank is given to them, right? Now in the next, it's going to start to skip all those the numbers. So here it was 3, and then it was supposed to be 4 here, but with the rank is the same number, right? So then it skipped to the 5. So now here it is going to be change 5 minus 1 and divided by 6, so it's going to be this percent rank. And then for the next one, so 6 minus 1 divided by 6, so you have this one, and then you have 7 minus 1, that's and then you have divided by 6 is equal to 1. Okay, so this is how you will calculate the percent rank, and I haven't seen much use of this one, but maybe there would be, you have more use of it. Now let's take a look on the other function called the cumulative distribution, and computes the cumulative distribution of values within a Windows partition, indicates the fraction of the rows in the current partition that are less than or equal to the current row. So that's it is a cumulative distribution of values. So let's execute that one, and first of all we are using the same data frame, adding a new column, cumulative distribution, and then say cumulative distribution over Windows specification, that is the partition, Windows partition by the department, ordered by the sales, and then we are going to go ahead and execute, and then we'll see the outcome. And here it is. You can see that for our first value in the HR department sales, it is 0.33. For the second one, it is a 0.66, and then for the third value we have a 1. And the same goes for the secondary marketing, has the same 3 records. Now for the sales, you have different values here. So you see that this is your first value for cumulative distribution, that's is a second, and then keep increasing as the row numbers are increasing or the ranks is increasing. So finally you have a 1. So I also have put this formula for cumulative distribution, and the formula cumulative distribution is the number of rows with the value less than equal to the current rows of value, and then divided by total rows in the partition. So the number of rows with value less than includes the ties as well. So right here, if we go for the sale partition, so here it is, that's our first row. Now in this case, what's going to happen, you have a 1 divided by 7, and then that's the value we get. For the second row, that's what it is, and now it is a second and divided by 7, so that's what it is. Now this is third and fourth, and you see that for the, as there are 4 values from here, so for even third is as ties happen, it is going to consider 4. So and the 4 divided by 7, and that's why we are getting this value. So due to tie, it is considering all these rows in the calculation. And then here you have this is our 5th row, and then divided by 7, and that's why we are getting this result, and then 6th and 7th. So this is how you will be calculating the cumulative distribution, and you will be using this formula. Very easy. I'm not sure where exactly you will use it. I haven't used it much, but again, it depends. So here we are going to take a look on the lag, and then a lag provides access to the data from the previous rows in the same result set without a self join. So offset specifies how many rows back to the access, and default is the return if there isn't a row at that offset. So let's take a look here. We are creating a new column called the previous sales by using with column function in the same data frame that we have created on top. And here I'm using lag, and I'm applying this lag on the sales column. And here is the offset value, and then here is the default value I'm providing. And then we say over Windows specification, that is partitioned by our department and ordered by the sale. So let's execute and take a look on the result. Then we will do some experiments and see how exactly it look. Okay, so here you can see that I have this HR department, and in the HR department we have sales that's already ordered by right there. And you see that this is the first row we have here. And for the first row, it is the put 0. That's the value we have put as a default. If you want to add to another value, we can always do that. We can maybe put null, none, or sometime any other hard value, we can do that. And here it is. So this value, this is your today's value. Let's say this is the January 1st, right? And now you're in January 2nd, and you want to see like, hey, what was the value in January 1st? So they took this value with the lag and put right here. So this was your previous value. You can see that previous sale, right? So you then for this 6100, and then this is happen on the 3rd of January, and you're like, hey, what was on January 2nd? So now you have 6,000 that comes right here. Okay, so it keep working in 4800. That's the first day of January. Okay, so you don't have any previous sales. And then you have 5100, but what was the previous for January 1st? You have put it here, and then again it goes like that. So 5600, then for 5100, that is for January 2nd, and that's come as the previous sale for the January 3rd. So you see right there. So that is how that's how it is going to work. So you can use lag when you need to use some previous values and want to show in front of it, and that's how you will do. It's very helpful, in many cases. And that's where I was saying, like, if you want to change the default to the maybe instead of 0 or something, you can always go and change. So let's execute and take a look now, and we should be getting a 10 here instead of 0. So that I put as a default value right there. But rest of that is going to be same. You have sale here for the next day, and the previous sale is coming from here, right here. So that's how it is. Now we are going to take a look on the lead function. That's similar to the lag, but accesses data from the subsequent row. So useful for the comparing current values with the future values in the window. So here we are creating a new column called the next value, and then we say lead, and then put a column on sales, and here is our offset, and then we have a default value, and then we say over window specification, that's partition by department and order by sales. So let's execute the lead now and take a look. So here it is, our this is our sales. So the HR department, the sale on the January is 5300, and then here you have 6000, and here you have 6100. Now as with the leads, is going to take the next day sales and put right here. So you see that. So we have taken this 6000 and put here on the January 1st, and then we have for this record we have taken 6100 and put right here. And for this record, as this is last record, there is no future value, right? So that's why you don't see that. And same happened for the marketing. You can see that this is your January 1st, and hey, what was the sale on my January 2nd? So you have put right here by using lead function. And same goes like, hey, for the last day I don't have any future, so that's it. And you can see for the sale department exactly the same values, but the last record doesn't have any value, as there is no future value present for that. So you will use the lead in this case. So this is really beneficial, the lead and lag function, when you want a comparison between previous and next values, and it will help. Now let's take a look on the nth value. It returns the value from the nth row of the Windows frame, and n is the one base, and from the first determines whether to count from the beginning or end of the window. So let's take a look how exactly this works. So here we are creating a new column called the second sales, and nth value, and I'm saying applying on the sales column, and saying take the second value and over partition by our department and order by sales. So that's what we are going to do right here. So it's going to get us some value from the second position in each of that partition. So here is the output for our nth value function, and you can see right there we have this department, and then we have sales here. So there are 3 records. We have been taking a look on these ones, and we want to see the second value, right? So this is our second, and that's what we have presented right here. So this has been printing for all the records, and the first one no, because we didn't had anything weak. And then again for marketing, so if we took the second value, then we keep printing that, and again here is the second one is 53, and that we has been printing right here. Okay, so this is our second sale. So you can often do in this cases where you're calculating where the second sale, third sale, and all that, and you want to give up some promotion to somebody, and you want to calculate for some people, you can do that in this case, you know. Or I don't know, the other scenarios, maybe in your case you need to have a presentation second or third or fourth value, so you can take from there. Now the last one is NTILE. So it divides the rows in a Windows partition into n approximately equal groups or buckets. Assign a bucket number from 1 to n to each row. So let's say here we have this data frame df, and we would like to create a column called quartile or whatever the you know, if we're just dividing into 4, and here I said NTILE equal to 4 over Windows specification and spec. Now if I will execute this code, what's going to happen is going to create 4 those partitions for us, or groups or buckets. So see right there for HR, and this is my first 3 records. So it says 1, 2, 3. So there are 3 buckets created. So for here also 3 buckets created for my marketing department. And then I have this sales department is divided into 4 buckets. So you can see that 2 records in 1, 2 records in 2, 2 records in 3, and then we have 4 records. 1 record in a 4th bucket. So this is also like maybe this will be more reasonable if I will do 2, then you will see more realistic scenario. Now I'm dividing my each department into data into 2 groups. So here you can see that HR has only 3 records. So I have 1 and 2. So 2 records went into the first bucket, and then we have second bucket, that's only 1 record. Marketing same, but sale will make more sense to you. So now we have 7 records in sale, right? So 4 records went into the first bucket, that's number 1, and then 3 records went into the second bucket, and that's how it is. So NTILE will help you to put the records in different buckets, and that number you can define between 1 and n, that it is your choice. So what I will do, I will put this code in the description, and you can experiment. I know this is a lot of things, and sometimes even I spend a lot of time even rank and dance rank to understand, these are complex scenarios, and I'm sure with the practice you will get expert on these. I thank you very much spending time with me and learning all these concepts. So please leave your comments and subscribe my channel, and I will see you guys in next video.